Hey everybody! So today we're going to be talking about parallel lines and proportional parts. So we are still talking about triangles. And as far as in class, these notes will actually be broken down into 2 separate days, but I'm just going to make the one single notes video so you have all of the resources in the same spot. So for our first theorem, the triangle proportionality theorem, it states that if a line is parallel to one side of a triangle and intersects the other 2 sides, then that line divides the sides into segments of proportional length. So what that means, if we have BE and CD, those are parallel. They're indicated by the little triangular marks. Okay, those parallel lines are going to divide AB and BC into proportional parts. Okay, or proportional segments. So in this case, AB and AE would be proportional directly, BC and ED would be as well. Okay, so an example of that, if we have triangle PQR, we're told that ST and RQ are parallel. PT has a value of 7.5, TQ is 3, SR is 2.5, and PS is what we need to find. Okay, so that is what's missing. So our proportionality theorem again states that if you have 2 parallel lines intersecting the side of the triangle, it is divided into proportional segments. So set up your proportion. We know that PT over TQ is going to be equal to PS over SR. Okay, so plug in the information that we are given. So we have 7.5 over 3 equals PS. You could put in X here. This is our value that we're looking for, over 2.5. When we cross multiply, we're going to get 3 times our length of PS equals 18.75. Dividing by 3, we get a length for PS being 6.25. Okay. So moving on to the converse of our proportionality theorem, we see that if a line intersects 2 sides of a triangle and it separates the sides into proportional corresponding segments, then we know that the line has to be parallel to the 3rd side of the triangle. So what that means, if we are given side lengths, okay, so AE over EB equals CD over DB, then we know that AC has to be parallel to ED. Okay, so an example of this would be in triangle DEF. Label our values. EH is 3, HF is 9, DG we're told is 1/3 the length of GF. Okay, so what do we need to do? Prove DE is parallel to GH, or determine if it would be. Okay, so first, thinking about my theorem, I know that in order for DE to be parallel to GH, I have to have proportional side lengths. So we can say EH over HF would have to equal DG over GF. Okay, so they didn't give me a length for DG. They just said that DG is 1/3 of GF. So I'm going to guesstimate or label DG as X. Okay, knowing that DG is X, I can say DG over GF is X over, remember DG is 1/3 of GF. Okay, so we can call GF 3X because 3 times 1, right, would give you your portion. All right, so breaking this down, we get a ratio of 1/3 for DG to GF. And then looking at our other example, EH, or our other side, over HF would be 3/9, okay, which reduces to 1/3. So, since both sides are proportional, or since all of our segments are proportional, we can say that DE and GH are parallel. Okay. So moving on to the mid-segment. All right, so the mid-segment of the triangle is going to be a segment that has endpoints that are midpoints of two sides. All right, and every triangle is going to have 3 mid-segments. So for example, if RQ is a mid-segment, it's going to be in relation to AB. Okay, so that's the opposite side that the mid-segment correlates to, where we have RP right here. So that is going to relate to CB. Okay, and we know that these are mid-segments because if you look at your endpoints, they cut the opposite segments in, or those portions in half. Okay, so the triangle mid-segment theorem states that a mid-segment of a triangle is parallel to one side of the triangle and its length is 1/2 the length of that side. So if we're looking at J and K, okay, these are going to be our midpoints. We know that the mid-segment has to be parallel to the side that it correlates with, all right? And it's going to be 1/2 the length of that side, right? So here, JK would be half of whatever length FG is. So if we're looking at an example of the mid-segment theorem, okay, we can look at our first triangle RST. We're told that XY and XZ are mid-segments. Okay, so XY and XZ are right here. Our first one we need to solve for, we need to find the length of XZ. Okay, so I know that by my triangle mid-segment theorem, XZ is going to be parallel to RT. Okay, and XZ has to be half the length of RT. So we have XZ equals 1/2. RT's length is 13. So XZ is a value of 7.5. Okay, looking at our next problem, we have to find the length of ST, which is this full side of our triangle right here. I know that the full length of the triangle is going to be twice as much as the mid-segment because the mid-segment is half. So if I say my mid-segment XY equals half of ST, okay, plug in the information I know, 1/2 ST, okay, we're multiplying by our reciprocal right here. Okay, so ST will be a value of 14. So again, with mid-segments, all you have to do is either go from mid-segment to full by doubling, or if you're given the full length, take half of it for your mid-segment. Okay, so our last one here, we need to find the measure of angle RYX, which is right here. Okay, and we see that we're given YXZ right here. The takeaway from this, think back to Unit 2 when we talked about parallel lines and transversals. Okay, so we know our mid-segments are parallel to those opposite sides. So if I was to extend my parallel lines, okay, I'll make a little note, these are parallel, okay, and then if I was to create or extend out this other mid-segment or my transversal, look at your relationship between RYX and YXZ. Okay, so I know that, let's make a note of what we did. So RT and XZ are parallel. Okay, and then let's see. We have this pink angle here and this pink angle here. When we're thinking of two parallel lines being cut by a transversal, we can say that their alternate interior angles are congruent. Okay, so let's make a note of that. the measure of angle RYX has to be congruent to the measure of angle YXZ because they are alternate interior angles. Okay, so that means that RYX will be equal to 124 degrees. Okay, so moving on from here, we are learning about the proportional parts of parallel lines. So we are told that if we have 3 or more parallel lines intersecting 2 transversals, then they cut off the transversals proportionally. Okay, so if AE, BF, and CG are all parallel, then we know that AB over BC will be equal to EF over FG. So we have those 2 proportional transversal segments. Okay, so let's look at a real example of that in the real world. So we're talking about art. Okay, so Megan is drawing a hallway in 1-point perspective. She uses the guidelines shown to draw 2 windows on the left wall, so these windows right here. If segments AB, BC, WZ, and XY are all parallel, AB equals 8 centimeters, DC equals 9 centimeters, and ZY equals 5 centimeters, find WX. So there's a lot of information, so let's draw a little picture. Looking at my information given, I am told that AD, BC, WZ, and XY are all parallel. Okay, so let's make a little note of that. So we're going to draw my parallel lines, okay, through my pictures. Okay, WZ and XY, they are all parallel. So we'll put our little triangles here so we know these are our parallel lines. Okay, I'm told that AB equals 8 centimeters. So right here is 8. DC is 9. So that's the bottom of my picture frame or my window. Okay, ZY is 5 centimeters. And I need to find WX. Right, knowing what I know about the, which theorem was it? The proportional parts of parallel lines, okay? I know that if I have parallel lines, aka my blue window lines here, that are cut by 2 transversals, okay, these dotted lines here, then my segments have to be proportional. So, if AD, BC, WZ, and XY are all parallel, then we know that our segment portions AB over WX, so that's this segment over this segment, is equal or proportional to DC over ZY. Okay, so take the information we know. AB is a value of 8 over WX, which I'm looking for, okay, equals DC, which is 9 over ZY, 5. Okay, so now we're just going to cross multiply, so 9 times our segment of WX will equal 40, okay, dividing by 9, WX will have to be a value of 40 over 9, or if we estimate that, it would be about 4.4. Okay, so the key with here is the proportional segments are the segments that lie on your transversal. So you put AB over WX. Okay, moving on, last little bit. Okay, so congruent parts of parallel lines. If, again, we have 3 or more parallel lines, they are cutting off congruent segments to one transversal, then they're going to cut off congruent segments on every transversal. Okay, so AE, BF, and CG are parallel, these pink lines right here. Okay, we're told that AB is congruent to BC, so since our 3 lines are parallel, we also know that EF will be congruent to FG. Okay, so in this Next and last example, we want to find the values of x and y. All right, we're told JM, KP, and LQ are all parallel. They're notated by the given information and the little pink triangles. We're also told MP is congruent to PQ, and we want to find x and y. JK and KL are also congruent. So we can make a little mark here. All right, find x and y. So what does it mean that these parts are congruent? Well, congruent means they are equal. Okay, so all you have to do here is take your congruent segments and set up your equation. If MP is congruent to PQ, then you can say that 3y plus 8 equals 5y minus 7. Okay, I'm going to move my y's first. So I get 8 equals 2y minus 7. When I move that 7 over, 2y equals 15. Okay, and dividing by 2, y is going to be equal to 7.5. So on our segment here, y should be 7.5. And then last but not least, again, JK we're told is congruent to KL, because again, this transversal is being cut by 3 parallel lines, or the parallel lines, yeah. Okay, so we have 6x minus 5 equals 4x plus 3. Okay, I'm going to move my x's first. You don't have to move your x's first. Okay, it's okay if you move your other numbers, your constants. That's okay too. Alright, so 2x equals 8. That means x will be a value of 4. Alright.